The level gauge on our oil tank no longer works because the float no longer floats, and I couldn't find any new ones that aren't sold out. So what I want to do is use one of these distance sensors, put that right about here, and measure how far down it is to the oil so I can read it inside from the computer. I hooked up one of these distance sensors to a Raspberry Pi, which was pretty straightforward, and I've got a Python script that just measures the delays, and that works surprisingly well even though I'm timing it with Python. So as I move this chair closer and further, the computer shows me how far away it is. And if I average a bunch of samples together and throw out the outliers, I get consistent to about 1 millimeter on these readings, which is really nice. So I might be able to graph how we're using oil throughout the day. This will connect to the header on the Pi, and I'm putting a 1K ohm resistor in series with a signal coming back to it, because I'm feeding a 5 volt signal into a 3 volt input. With the sensor on the top of the tank, I figured condensation might happen. So to protect against that, I wrapped this one in lots of electrical tape, and that goes into this thing here. That's going to plug into the top of the tank. So this replaces the fuel cap, and it's going to stick into the spout like this. I've plugged my long cable into the Raspberry Pi and the sensor unit, and surprisingly it works. I got the new wire plugged into my shed Raspberry Pi, which is also connected to Ethernet, power, camera module on the other side here, plus this wire goes to a temperature sensor. And this wire goes this way over to the oil tank, over to my sensor, and I've got this little plastic container to protect the connection from the elements. I'll open the oil cap and stick that in there. Now I gotta go inside to see if it actually works. And it didn't work, so now I'm debugging things. So I've got another Raspberry Pi right here that I plugged my cable into and tested it from there, and that works. So somehow plugging it into this one didn't work, but I'll try it again. And now it works. I don't know why it didn't work before. I suspect I may have logged into the wrong Raspberry Pi when I tried it. I graphed my distance readings over 3 days, and it seems to be going up and down quite a bit. Not surprising, because oil shrinks and expands with temperature quite a bit, but there's a rather large step here and then going back up, and that's a bit odd. So I've been scoping out the analog waveforms on the transducers on one of these things using my USB scope, and what gets sent is 8 pulses at 40 kilohertz, and this is what comes back. This is at a different scale. And each of these cycles is 1/40,000th of a second, which corresponds to a sound wavelength of about 8.5 millimeters, or about 4.2 millimeters for round trip time. So gauging the position of this pulse off by one cycle, which is not difficult to do because there's no discrete edge to it, would make a 4 millimeter step. But beyond this big step, everything seems to be moving in steps here too. There's a little bit of noise in the timing because my Python code is not that accurate timing-wise. But these steps aren't all the same size, so I played around with this and I changed my grid lines to be 0.6 millimeters, and these steps all seem to fall on the grid line. So basically the resolution is 1 millimeter and then rounds it to the nearest multiple of 0.6 millimeters. I don't know why they do that. But there did seem to be some kind of downward trend in my oil levels, and I was wondering, what if we're leaking oil? But looking at a 5-day graph, you can see the oil level does seem to be coming up a bit. I've got the distance scale upside down here because less distance means higher oil level. And you may notice starting here, the signal is not as jaggedy as it was here. I rewrote my distance measuring code in C here so I could time it much more accurately. I finally turned on our old oil-fired burner this morning. Oh, there, it's just come on again. There's the burner, and this heats up the water that circulates through radiators in the house. We also actually have a wood-fired boiler, which is kind of handy for getting rid of scrap wood. And here's a graph for the last 24 hours. This here is at 7 a.m. when I turned on the boiler, and the oil level has dropped since then by about 6 millimeters, which, given the price of oil and the geometry of the tank and all that, is about $4.40 worth of oil used. The way these sensors work is quite fascinating to me, so I've actually put pigtails on there so I can see what's sent out and the echo. And right here I'm actually tracking it a little bit. These are about 25 centimeters away, these pieces of Lego, but mostly it reads 40 centimeters for the distance because I spaced those two so that the echoes from them will interfere with each other. And so if I just move one of these by just a tiny bit, like this, that will make it correct. And with that bumped a little bit, the echo signal is now also much stronger. But still, it's far from clear exactly what the delay here is. And this thing must do quite a bit of signal processing. So now instead of looking at what comes out of the analog thing, let's look at the pulse that this thing sends out. And we look on here, the pulse, the analog echo was here and the pulse is way out here, and even the position of the pulse with respect to the signal here changes a bit, especially as I move things here. So clearly the pulse does not correspond directly to the time that the sound travels, but is sent out way after the fact, after the little signal processing chip on here is done figuring out what the delay should be. And the more I play around with these sensors, the more I'm amazed that they work at all. I'm just glad I can now read my oil level from the computer.